Dear students of B.Sc Part 1 and respected listener, a very good afternoon and welcome all of you to today's lecture. Dear students of B.Sc Part 1, I am going to deliver today a very special amazing lecture on methods to write the velocity of the reaction for reactant and products, which is selected from B.Sc Part 1 Paper 3 Physical Chemistry, chosen from Unit 5th title as that is of Chemical Kinetics. I bring to draw your kind immediate notice on our previous lecture, dear students of B.Sc Part 1, in which various cases we have discussed, delivered in the classroom, in which that is of case 1 we have calculated the value of concentration when in any chemical reversible reaction A plus B to react that to produce that is of C plus D as a that is of product here. So suppose CA, CB, CC and CD denote as the concentration of A and B as reactant and C and D that is a product here. In such a position, by considering as reaction is moving forward direction, such a position concentration of the reactant decrease here and the concentration of the product increase here. So I mean to say, dear students of B.Sc Part 1, here in our previous case 1 we have calculated the value of reactant and product in terms of concentration. Second one case, we have also determined the value of velocity of the reaction for reactant and product in terms of active mass. Active mass is nothing but, according to Goodwork and Voges, the number of moles present in unity volume. Law of mass section is known as that is active mass. Suppose active mass, the concentration active mass of reactant and product one can write in the form of large bracket minus the active mass of A upon dt minus d active mass of B upon dt plus dc active mass of C upon dt d plus active mass of d upon dt here is in our fundamental the postulates of velocity of the reactions as reaction undergo. During the changing of the reactions, the concentration of the reactant decreases. I mean to say, we have to write down negative sign for reactant, and concentration of products increase to, we have to write down that is a positive sign here. Third one case, we have also calculated the value of in terms of degree of dissociation. Dear student, in our previous lecture, the next one case we were expressing how will you write the velocity of the reaction for various reactant and product in terms of degree of dissociation. Firstly, I define here that is the degree of dissociation, the number of totally present and its fraction react in chemical reaction for the formation, for the production of the product. Such quantity is known as that is of degree of dissociation and is symbolized by that is of small x also. We have also calculated here the value of velocity of reactions for reactant and product A, B and C and D to possess that is of the same value dx by dt here. In our previous lecture, T is equals to 0, A and B reactant to have its initial A and B mole. Initially, C and D produce at 0 at T is equals to 0, A minus X, B minus X to produce that is of twice X. And on the behalf of the fundamental concept postulates of chemical kinetics, all reactants and product to possess to have the same dx by dt value here. Dear students, now we have also further case we have expressed in the classroom here, we have also calculated here. How will you calculate the value? What is the method to write for velocity of the reaction for those reaction reacting into that is of n is to m reaction, in which various examples n1 mole of A reacts n2 mole of B to produce m1 mole of C and to produce that is of m2 mole of D here. And we have calculated here the number of moles for calculation for determining the various velocity of the reactions A, B, C and D by means of reactant and product. Directly number of moles will be written in the form of fractions. Rest postulates theory will be written as such. I mean to say, for reactant negative sign and for product positive sign will be used here. Next one case I will deliver today among the students also. That is, I will calculate the value of partial pressure, the value velocity of the reactions, velocity of the reactants and product here. My question to all of the students here, dear students, what do you mean by partial pressure? and where we will determine the value of velocity of the reactions here. Dear students, in our previous, once again I focus, I repeat that all the reactant and product present in that is of liquid and that is of solid phase, in such a position one can determine the value of that is of minus dc upon dt, or in another modified form that is of active mass, in another modified further form that is of mole per, that is of liter for liquid and solid also. In such a case, when all the gases are present, when all the reactants are present in gaseous state, in such a position, we will determine the value of velocity of the reactions here. It is totally out of a different case here. Here 1 mole of N2 present in gaseous state. Similarly here, thrice mole of H2 present here, that is of gaseous state, and twice mole of NH3 present, that is of gaseous state here. 1 mole of N2 takes thrice mole of H2 to produce twice mole of NH3. The students, one thing I describe here, that is of negative sign, N2 here negative sign, H2 here negative sign. Why? Because N2 and H2 thrice mole present here reacting in the form of reactant, so obviously there is no doubt negative sign will be used here. I mean to say minus minus. In our previous fundamental postulate N is to M reaction, the 3 number of moles which is directly multiplied to H2 now will be written in the form of fraction minus 1 by 3, and similarly twice mole of NH3 is produced here in the form of product here. Here twice mole of directly is multiplied by that is of NH3 in gaseous state, so one can write in the form of fraction here, or rest positive negative sign will be mentioned as a such here. So I mean to see here partial pressure, that is the fundamental property of all the gases here. So it is the method to write for all the gases velocity of the reaction, because here concentration of the gases are expressed in terms of partial pressure here. And dear students, B.Sc part 1 specific example and types of velocity of the reaction we will deliver in the classroom tomorrow. Thank you very much.